Hey guys, starting right where we left off, here's the last bit of it, and we're still doing the growth and decay formulas to find different types of examples. So we had the growth A of t was 1 plus or minus r to the t being time, or just using y. It didn't really matter as long as you had that 1 plus or minus r and the exponent in the right place, you were good. Okay, the value of a truck bought new for $28,000 decreases 9.5% each year. Write an exponential function and graph the function. Use the graph to predict when the value will fall to 5,000. Okay, so we're going to have y equals your initial value. Oops, forgot that in both places. Your initial value, 28,000, times, now in this case it's a decrease, so you're going to have 1 minus, and remember that's got to move over to 0.095 to the x. Okay, so putting that together, we can get a calculator here. All right. You can use your Desmos if you want to. Get to the next one here. 1 minus 0.095. Okay, and there you go, 0.905. So you get about 90% of it each year. So y equals 28,000 times 0.905 to the x. Okay, so we're going to do exactly what we did before because we want to see where the y value gets to $5,000. So we're going to go back to Desmos and put this in. So y equals $28,000 times 0.905 to the x. And then we're going to do settings. We're going to add a table. And we're going to see what happens. Okay. So 3, 4, 5, 6. Just keep going. And so between the 17th and the 18th year, you would get it down to $5,000. Okay, so it's not too tough to put it in there. Calculator there. Your y will be approximately 17 and a half years. Okay. So it's not so tough to do that. Like I said, we will be learning later on how to do it so that you get an exact answer. These are just estimations. Okay, compound interest formula is usually what you're dealing with. And this is where you're dealing with a number of times per year that it is, you're getting interest. So the formula is A, accumulated amount, equals P, which is called your principal, times 1 plus your rate divided by the number of times per year it happens, all raised to the number of times it happens times the time you're going to leave it in there. So, determine the amount of money in a money market account providing an annual rate of 5% compounded daily. If Marcus invested $2,000 and left it in the account for 7 years. So there are 365 days a year, and it's compounding every day. So your accumulated amount would be $2,000, that's your principal, times 1 plus 0.05 divided by 365 to the 365 times 7. So to put that in your calculator, I do it actually usually a particular way when I'm trying to put it in there. I will put in the R over N first. Okay? So that 0.05 divided by 365, 0.0001, blah, blah, blah. So that right there becomes 1 plus that 0.0001, blah, blah, blah. So I go ahead and add that as my second step. That is my first step. That's my second step. Okay. It just makes it easier, since I'm having to flip back and forth, to know what I'm doing. All right, so I'm going to add, let's see, can I take that with me? I don't know about that. 0.0001 36986 30137 plus 1. All right. Whoops. I hit the equals. Okay. So I get 1 point that. All right. So let's go back again. 1.0001, blah, 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 blah. All right. Raised to the 365 times 7. Well, since I'm not carrying things over, I'm going to do the 365 times 7 right now. And get that done next. If you've got a TI-84, you can do it in this order. And it will bring back stuff for you. So 365 times 7, 2555. Okay, so I have that 1.0001, blah, 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 to the 2555. And I'm going to get all that done and then multiply by 2,000. That I can do in one line. And the reason that is because I can put in parentheses with it. All right, so I've got 2,000 times, and there's my number that I need, 1.0001 369,863. All right, and that is raised to the 2555. And there we go. 2838.07. You want to round it off to hundredths because you're talking about money. So you go with cents. 2838 and 7 cents. And there's your answer. 2838 and 7 cents. Okay, so it's not that hard. It's just getting it into your formula first. If you can get it into your formula, you can calculate it pretty easy. All right, the compound interest formula, again, it tells you what it is. T is in years. Harry invested $5,000 at 5% interest compounded quarterly. So this time, he's got $5,000. And the rate is 0.05. And it's compounded quarterly, which is 4 times per year. In case you don't know, and you might not. Doesn't come up very often when you're a teen. Quarterly is 4 times a year. Biannually is 2 times a year. No, that's every other year. Semi-annually is 2 times a year. Sorry. Always have to think for a second. Semi-annually is 2 times a year. Annually is 1 time a year. Monthly would be, of course, 12 times a year. Okay. Biannual would be every 2 years. I mean, once every 2 years. So, right here, we've got to the 4 times and 5, because the first one is how much will it be worth after 5 years. So, let's go put it in, since we've got things we're not looking for. We'll put it into the thing, and we'll let it have a table. Y equals 5,000 times 1 plus, and you can do this on every one, 0.05 divided by 4. Close that. Close. There we go. Close that. And then close that. I actually don't want that. Okay, there we go. And I'm going to raise that to 5 times 4, which is 20. There we go. It'll be worth $64.10 and 19 cents. So it makes it pretty easy. $64.10 and 19 cents. When will the investment be worth more than $10,000? So you've got this, only you're going to put it to the X, or to the T, for T. We'll use Y and X at Desmos. And then you'll have to put that table in. Okay? And you want it to be $10,000. So we're going to go back to Desmos. And I've got this all in, except now it is to the 4. I wonder if it's still raised. To the 4x. Okay? So we're going to back up and get our table. And here we go. It tells us. So we're going to start just hitting enter and keep going down. We want it to get to $10,000. And there we go. 14 years to get to $10,000. So come over here. And the answer is 14 years. Okay. What if Harry could have invested the same amount in an account that paid 5% interest compounded monthly? How much more would his investment have been worth after 5 years? Well, this is the same thing we had, except for the fact that you'll have a 12 on the bottom, and then it'll be 4 times 12. It'll be 12 times 5. The 4 is the number of times per year, so you'll have 12 times 5. So we'll go back to Desmos and put that in and get our answer out. Okay. So right up here, we'll put in Y equals 5,000 times 1 plus 0.0, whoops, wanted to put a plus, parentheses, 0.05 divided by 4. Okay. Parentheses. Raised to the, and you could do it all together. 12 times 5 is 60. There we go. $10,535 and 91 cents. So that's what it would have been worth. That is not what they asked you. They asked you how much more. Make sure you read a question. So you would actually have to subtract this off and tell me what it equals. Whoops. And I've run out of time, but I'll put that as a question on one of your things to see if you got your notes.